Now we've seen cross-validation in action, let's see some other important classification model evaluation metrics. And to do so, we're going to start a new heading here. It's so important to evaluate our models. Evaluation metrics. And the four main ones we're going to cover for classification models: accuracy. The next one is area under ROC curve. And don't worry if you're not sure what these are, we're going to go through them. The third one is a confusion matrix. Sounds fancy, right? And the final one is a classification report. So to start off, we'll keep it nice and simple. We'll do accuracy. So we'll remind ourselves of how we can train a machine learning model and evaluate it by importing cross-val score from scikit-learn's model selection. And then we'll import our random forest classifier. Wonder if we can press tab. Yeah, there we go. Beautiful. We'll set up a random seed. And then we'll create our X data. And we'll create our Y data. Beautiful. Now we'll set up a test and train split. So we'll go here, X train, X test, Y train, Y test. Oh, actually, we don't need to because we can just use the cross-val score. So let's do that. We might put a little heading up here to make sure we know that in this case we're doing accuracy. CLF equals random forest classifier. And then we'll print out the cross-val score by passing it our classifier, our X data, and we'll do 5-fold cross-validation. Wonderful. So here we go. We got number of estimators will change. Getting this classic warning. So this is just a reminder. We can set number estimators to 100 and that'll get rid of that. Beautiful. So what this is going to give back is because the default score parameter of our classifier is the mean accuracy, this is what the cross-val score is measuring here. Actually, we might save this to a variable, cross-val score equals that, run it again. And then if we take the NP mean of cross-val score, we've seen this one in the cross-validation video, this is going to give us the mean accuracy of our model. And basically, this comes out as a decimal, but we can easily type this out to be print, actually F, heart disease, classifier, accuracy. So whether or not our model can classify whether someone has heart disease or not, given their parameters, we want to put in here np.mean cross-val score. We're going to times this by 100, and we want 2 decimal places. We maybe need a percentage sign on the end here. Beautiful. This is going to be cross-validated accuracy, actually. So that's important to note. Cross-validated accuracy. So that's not too bad, right? And what accuracy is actually saying is, given a random sample, given a sample that our model hasn't seen before, how likely is it to predict the right label? So if we have a look at our heart disease data, we might do it under this cell so it doesn't interfere with our scikit-learn code. Heart disease, .head. So given a sample that looks like this, has age, sex, CP, TREST, TB, PS, COL, FBS, all these features, given a sample like that to our trained model, how likely is it to predict the right target? And in our case, our model's cross-validated accuracy is 82.48%, so around about 82.5. So that means 82, or about just over 8 times out of 10, our model will predict the right label given a sample, something like this, based on the original training data. So that's accuracy in a nutshell. What we're going to dive into next is area under the ROC curve. And if that sounds confusing, it's a bit of a mouthful, but we'll go through it. So that's kind of how you would present your model's accuracy. You'd print out something like this. Again, it returns by default a decimal. In communication style, it's easier if you represent it as a percentage.